Institute. And today we'll be having the webinar is titled AI-enabled food systems, food access simulation and modeling to enhance food security. And it will be presented by multiple people of the team. It will be starting with Song Gao, and then I think Michelle and Alfonso will also be presenting. Is that correct? Yes. So Song, please share your slides and let's get started. And everybody is welcome to attend, ask questions while the webinar is going on so that we can try to have it in a more interactive mode.
Yeah, just checking. Can everyone see my slide and also hear my audio?
Yes.
Okay. Yeah, thank you, Dr. Panda, and hello, everyone. Yeah, this is Song. I'm a member of the ICICLE Institute, and today we are very glad to present the AI-enabled food system and about food access simulation and modeling to enhance food security. And just to start, so our goal of the presentation is sharing some of the research progress within ICICLE. We are trying to develop the latest AI and the cyber infrastructure components to enhance the food access and security. So as we know, the food security is a global issue and it involves multiple aspects, such as the food availability and linking to the digital agriculture and the food access, food stability and utilization. So within ICICLE, we have been made different aspects and trying to model the food access flow from the national scale and investigating the regional food logistics and also the local food access simulation. And through all different scale, we also consider the important data privacy protections into those digital infrastructure. So we are going to present one by one. And just some of the research highlights we have made within the ICICLE. And from the national food flow perspective, we have developed a data API, which stands for the Application Protocol Interface, which is a programming interface and to support the flexible data access. So I will talk more later. And also we have developed a scalable food flow model using deep learning. And in the regional food logistics, and we have developed some of the data generation and the optimization tools and for the local food access and security. And we have developed the agent-based modeling and to do the simulation and support decision-making planning. And regarding the data privacy, accountability, and data integrity, which are very important for the digital infrastructure, we also have developed some of the security sandbox, and we will later show you a demo today. And regarding their contribution, and then especially from our vision perspective and involving those multi-stakeholder process to produce or develop solutions, we are trying to develop those plug-and-play AI solutions. This is also key effort in the ICICLE Institute and trying to democratize AI and through those both professional and also the expert AI developer, as also those public nonprofit stakeholders working together to democratize the AI access. And we're also trying to contributing to those computing continuum, and we'll talk more through this presentation. And we also have a multiple software components released, and we also present one by one. So the first one is at the national level, and within the ICICLE team, we have been collaborate with the multiple institutions and have developed those data API, which actually linking to the national level threat analysis framework, which is from the Department of Transportation and Rural Transportation Statistics. So as you can see, on the screen on the left, so this is actually the front-end interface support the user to actually flexibly select some of the food categories and also the specific time periods, and then can get those different statistics about the food flow between different regions at the US. You can also customize by different transportation modes, such as by air, by train and also by land and so on and so forth. And also for developers, so you can see the API, on the right side, and you can also customize based on those standard, Rust API. Programmers, they can write the scripts and can customize so their needs, so they can load the data on demand. So this is very important for those data-driven predictive modeling in AI. So this actually is a very important public statement, and we have been working with the DOT, and we are very also proud to announce that on March 19th this year, and the DOT Rural Transportation Statistics has also approved our API for the public release. So you can also check out our hosted the URL and services on our TAPIS API hosted by ICICLE. And regarding the AI-enabled food flow modeling, we have also trying to understand the different food flow characteristics and the spatial patterns and across different regions as well as per food category. So we are using the USDA, the standard classification of transported goods, so which stands for SCTG. So this is one of the standards widely used in the digital agriculture. And for example, we use a SCTG. So the 2-digit 05 to represent the general categories of meat, poultry, fish, and seafood. So that is the figure on the right showing the overall total mass distribution about different food categories in the US. And we developed this food flow GN deep learning model. Essentially, it's a scalable food flow model, and that can predict the different food flows between both the 5 zone levels and also the different counties. So that are two different geographic scales. One is around over 100, but the other is over 3,000 counties, which is a very fine granular level, which is not achievable without those AI advancements. And one of the innovation we made in this development is actually we try to train the model on the coarser spatial scale and trying to predict the food flow at the finer spatial resolution at the county scale. And we actually achieve a very good performance on certain categories, but we also found some of the variability across different categories. So that's still some area where continuing improvement. And we also publicly release this model on our ICICLE AI category, and also both GitHub and also Hugging Face. So people can also reuse and also further improve our model. So some of the detail about this model. So this is a workflow about the national scale food flow modeler, and it involves 3 components, as you can see. So from the data collection and curation, as well as we prepare, process the data for their deep learning ready, and such through those, for example, the mini batch data sampling, and also the model training, and which actually supported by those ICICLE CI resources. And then on the edge, so the edge for us is more about the web interface. So we can deploy our model on their web portal you will see next, and then you can also explore some of the patterns you may find from our modeling results. And this is just a quick snapshot about the results about our modeling from different food category I mentioned earlier for those 7 general food categories. And the figure or the maps on the right showing those food flow patterns. As you can see from the coarser, public available from the sensors, the 5 zone level, you can actually not, see those more detailed, concentrated, for example, those, more granular, food flow patterns concentrated in the Midwest region, which is showing on the, map below. So which is enabled by our county level food flow modeling. And also we develop those geo-visualization web portal, so such that not only developer but also actually their potential users can actually browse those data-driven food flow patterns in the US. So you can select different regions and then understand by food category. How are there, the food supply, for example, for certain categories, how much food coming from for specific zone or specific county. And then this is very important. And imagine this because this is a modeling effort. If you change certain region, input, for example, under certain disruptions, we can actually update this model and generate the predictive, impact for the food, import and export. So this is very important for food planning, especially under those disruptions or emergency for the food security. So with that, I will invite my colleague, Michelle, to talk about the regional level.
Thank you, Song. That was great. I learned a lot from your presentation. I'm going to talk a little bit about our work on regional food logistics. Labor and fuel costs drive logistics decisions for commercial distributors, and many of them have their own in-house logistics segment that helps them reduce costs. Others, smaller distributors will have third-party logistics company help them make those decisions. But the third-party logistics is expensive and out of reach for small regional food distributors. So on the left, we have a map showing one of our community partners and the routes that they're taking. They, up until this point, this had all been in one woman's head, how they were going to move product. And so putting it on a map was really helpful just to visualize the kinds of routes that they were running. The photograph on the right shows you the community of people who work with that distributor so that they could also understand visually what was going on in terms of delivering food for their communities. Next, please. So vehicle routing is a problem, a common optimization problem in logistics, and it's used to minimize freight costs by a fleet of vehicles operating out of a base. This spreadsheet is something that was developed in 2016 or 2017, and it gives you an idea of the kinds of data that was necessary to collect for a small company to use an Excel spreadsheet to make some of these routing decisions. The VRP is in need of revision for a couple of reasons. First of all, we want to use this spreadsheet to get an idea of what the food distribution system might be like in 2028. We want to think ahead and be able to make some decisions based on that. Another issue with the current spreadsheet is that Microsoft is discontinuing Visual Basic for Excel. And so it needs, all the back end of this spreadsheet needs to be revised. So we're going to be moving it to Jupyter Notebooks and using Python to do that. And then the third thing is that the scenario that we're looking for is going to be based on a USDA program called the Regional Food Systems Infrastructure Program, where contracts are in place to expand food infrastructure and in our region, develop a hub and spoke collaborative distribution model. Next slide, please. So the first thing to know about what's going on with regional food logistics is that in real time, we're seeing a pivot in distribution because several federal programs have been terminated in the last few months. So many of our partners are scrambling, trying to figure out how they're going to move product and trying to develop collaboration very quickly to make that possible. Another thing we need to do to be able to figure this out is access the data. We're looking at both public and private data. We have a partnership with a distribution co-op for private data. This distribution co-op was using, moving food for the USDA local food purchasing assistance program. And so they've offered to let us use their logistics data to develop the model. And then the state of Wisconsin required a FOIA to access the RFSI infrastructure data. This is 71 grants that were made in the last year, a $27 million investment in trucks, cold storage, processing, all to be added in the next 3 years. finally, we needed to be able to generate data to develop the predictive model, especially in its early stages. And then ultimately, all this will be linked to the privacy sandbox. This will allow tribal governments and businesses to use the models with their proprietary data. Next slide, please. So this is an example of what we're doing to generate data for the to develop the model. We're using a food hub as a depot. We have a 400-mile radius maximum. That would be one overnight for a driver. Most of regional food is delivered in 1 day, but there are some overnight excursions, especially down to Indiana from our region. So we wanted to be sure to include that as an option. And then we have type, capacity of vehicle, type of product, and temperature requirements. Next slide, please. So our timetable for this project is, first of all, we're iteratively developing the predictive model as data becomes available. We just secured 2 major data sets this last week. And so that should make it possible for us to move forward on that, on developing the predictive model. We'll be releasing the tabular data generation model in August on the ICICLE GitHub. So if you're interested in that kind of a model for logistics, it will be available then. We'll be presenting a scenario to community partners, we're hoping by early August, and this will be an opportunity to ground truth that model. And then improvements to the model will be made, and we'll rerun the scenario and present to community partners and to the public through a webinar to be announced. So keep your eye out for next fall for a webinar. And with that, I'll pass it to Alfonso.
Yeah, thank you, Michelle.
Thank you, Michelle, Song, colleagues. Whenever you're listening to this, greetings to you from Madison, Wisconsin. I'm Alfonso Morales. I'm Vilas Distinguished Achievement Professor in the Department of Planning and Landscape Architecture, and I have the privilege and honor of being the campus principal investigator for this project. Grateful, of course, to DK and Lima, who are our principal brain trust, along with the others on the executive leadership team, and very thankful to see folks in local government and food systems, food security organizations represented on this call. Please remember the recording and share it as you see fit, okay? So we have an agent-based model. That's the basic thing to talk about here, irrespective of what it's called. The Food Access Strategy Simulator was a name for it originally, and through work with stakeholders over the last 18 months, we've landed on the Food Equity Access Strategy Technology, Simulation Technology, the FEAST. So the FEAST, we hope, will be a service that ICICLE provides to users in local government, nonprofit organizations, and others nationwide, hopefully during this calendar year at some point. The point of the software is to address problems folks have with public support, real-time volatility. Again, as Michelle mentioned, we just don't know what's happening with federal government policy, how that impacts state and local policy. And yet we have organizations and local government attempting to address food access problems in the communities that they serve. So those folks can use predictive tools to support their decision-making in public investments. And I'll give an example of that in a little bit. They need predictive tools to respond to emergency situations, as Song was just mentioning. And if possible, they need tools that reach across all the way from local scale, what I'm talking about here, from a neighborhood scale or a city scale, all the way up to large regional and national questions. So our solution was to create an agent-based model for a decision support system that functions on all users in problems of different contexts. I apologize. Sounds like my neighbor is mowing their lawn. What a shame. So our process was to establish a stakeholder group that's been meeting periodically and to incorporate our colleagues and other ICICLE professional groups to get to make the software, to optimize the software, to work with reference architecture and ensure that our tools are integrated with other ICICLE tools, and to enable privacy. And I think this is super important. I'm going to go ahead and get up and move a little bit so that y'all can hear me better? Song, would you please change the slides for me? Thank you very much. So our stakeholder group is the first part of our cyber infrastructure. As everybody knows, without the perspectives of others about the solutions that are being proposed, we don't get to propose solutions. So it's through user perspectives that has been democratizing the AI and enabling an end-to-end design that we've developed. Our model initially is for a small neighborhood in Franklin County, Ohio. However, we will model the entire county pretty soon. What does that mean numerically? Well, what it means is that in this neighborhood we're talking about as a neighborhood of about 3,000 households and associated food businesses, grocery stores and whatnot. I'll explain that more in a bit. Franklin County is about 340,000 agents, households, and businesses. So that jump in scale requires more computational power, for which ICICLE is well suited, and we're able to display that computational power on behalf of users. We're testing the idea of a service by expanding the model to Brown County, Wisconsin, the home of Green Bay, Wisconsin, in order to enable that county to do emergency preparedness. They lie at a very low level, and many food businesses and transportation modalities to get to food access, to get to grocery stores or convenience stores, are threatened by flooding. So what happens? How do food access scores change? How do people's access to food change under emergency conditions? So currently, our research that's ongoing, it includes validating our models and establishing the compute parameters by the number of agents that are in the model, and then researching new models. For instance, the city of Madison, Wisconsin has a program to support small brick and mortar entrepreneurs in making food more readily available in underserved neighborhoods. This tool will enable that city program to make those investments more wisely by introducing into the model the consequences of investing in small brick and mortar food in order to enable them to supply more and different kinds of food in their neighborhood. This has both cultural relevance, depending upon the ethnicities served in the particular neighborhood, and this has food access as consequences, since large corporate grocery stores don't always want to set up in smaller, low-income neighborhoods. So that's a little bit more elaborated example. Song, could you go backward one more time? Give me 1 second. We're establishing a key performance indicators dashboard as well, and upgrades to the user interface. So this will enable users to, without knowing a lot of coding, without only having their problems in mind, be able to address the various needs that they have in their space. Now, Song, please go ahead. Thank you. Here's our basic workflow. Like a lot of ICICLE workflows, we care deeply about stakeholder engagement. However, for us, that concern is totally end-to-end. Stakeholders have been integrated into this process early in the game. Thankfully, Feeding America is on this call. Thank you, folks. And then, of course, data collection and pre-processing. We use census data in the model. And very importantly, and I don't have it in a box because I want to highlight this, we've been working for almost 3 years, I think now, with our colleagues at Case Western, whose work you'll hear about in a little bit, establishing privacy protections to enable folks to bring their own data into this framework. And so then relate their private data to public data to enable them to make data-driven decisions to support their decision-making in with respect to their implementing their programs and activities. Next slide. Thank you, Song. So let's do this demo here to give you a chance, and I'll talk you through it right now. This is for a neighborhood just near the Ohio State University in Columbus, Ohio. We have here a hexagon representing a large regular corporate grocery store. Here's another grocery store. And the map you'll see of the neighborhood also includes small convenience stores. And the decision maker may want to find out what happens if a store is opened or closed in an area. There you see we had an area of red households indicating low food access, and that low food access is determined by demographic characteristics like size of the household, income of the household, vehicles in the household, and other related data. So then as the decision maker contemplates the situation, they think to themselves, well, what if we can enable the creation of a grocery store in that location? What happens if we engage a process that finds a retailer and puts them there? Now we have a step process. The step process can be executed a day at a time, or a week at a time, or a month at a time. And so we start stepping through the consequences for food security. And as you can see right there, after a few months, people's habits have changed, and all of a sudden there's more food access in that neighborhood. Likewise, corporations may find themselves closing stores. We see this actually with some frequency around the country. And so when a store gets eliminated from a food environment, what are the consequences for food security? Well, we start stepping through that situation, and we see that our new store picks up some of that access, but not all of it. More folks are food insecure. So this hopefully gives you a sense of how perspective of users and a software development process is producing decision support solutions for folks. And so this is the impulse of our work. And obviously, if you haven't thought this idea already, you can see how these are all nested together. That is to say, the national and the regional and the local all fit together with other existing platforms, such as the farm2facts.org platform here at the University of Wisconsin-Madison that supports local food systems in different parts of the country currently. And so integrating across these platforms will be a major goal of the Institute in the future, and we are looking forward to that task. Now, as I indicated, it's very important to recognize privacy considerations, and again, thankful to the colleagues who have presented. Let's turn now to our colleagues at Case Western, who will tell us about the privacy work that they've been doing over the last several years. Thanks for your attention, folks.
Yeah, thank you, Alfonso. Yeah, now let's welcome Sama from the PADIS team.
Osama, you can take it over.
Yeah, you are mute. Maybe you are muted.
Hello.
Yeah.
So, hi everyone. My name is Osama Zafar. I'm a PhD candidate at Case Western Reserve University. I'm working on a food security sandbox. It's a web-based platform that allows farmers to be able to share data and allows researchers to uh, um, be able to leverage the data in a privacy-preserving manner that protects and safeguards farmers' privacy and their data. So we allow machine learning model training without actually sharing data sets and allow data set exploration and stored on distributed setups that farmers own on their end. So this allows for farmers to not only benefits researchers in terms of being able to leverage the data, but also helps farmers to identify similar farmers based on their farm profiles without actually sharing or risking exposure to their sensitive data. The so the two main functionalities that we have implemented so far is being able to identify similar farmers and being able to train machine learning models without exposure. What we plan to do in the future is to link a public-private data set to expand scope and possibilities for training more enriched models that are not currently possible due to privacy risk and hindrance of lack of data availability, and come up with a pre-processing and data privacy algorithm implementations that allow data sharing in privacy preserving manner. So it could be utilized by researchers to further the research in domain of digital agriculture. So the general architecture of the sandbox looks something like this. We have a front-end portal for the users to be able to use, and we have an application server that deals with all the calculations and the aggregations and all of that. And we have a farmer server. Which is a sandbox dedicated server that executes farmer and or edge computing and things. We understand that a lot of small scale farmers lack the resources and infrastructure to host these kind of servers. So we have developed this server that could be that is online and where the farmers can securely share their data which only they have access to, but the server can load the data in a sandbox isolated environment, execute and train models on it, and then send the updates back to the application server. Chala?
Hello. In the privacy risk quantification part, we are trying to apply the recent technologies. Either we are developing them or we are using the existing technologies. And we are trying to integrate these components into the web-based sandbox environment. And for these efforts, we have recently developed a query efficient privacy attack and risk quantification technique which assesses the vulnerability of neural networks trained on tabular data. And as a use case, we used membership inference attacks, which is one of the most prominent privacy attacks existing against the machine learning models. And we used as a novel approach to use model extraction as a precursor under label-only black box access settings. From black box access settings, we mean that we don't know anything about the we might know something about the architecture, but we don't know inherent model parameters, and we have only access to the labels of the models, not like the confidence vectors. And our preliminary results on the benchmark datasets of location, purchase, and the other one was Texas hospital dataset shows that with approximately 100 times the size of training models, target models training data, we can extract stolen models up to 90-95% similarity, meaning identical labeling, that exhibit also identical membership inference properties to the original model, which leaks lots of data, information about the training data of original model. We submitted this to NeurIPS 2025, and we are still expecting to hear from them. Hopefully this July we will hear from them. And we intend to integrate this study as a privacy risk quantification backend for the web-based environment, and we plan to use them for targeting tabular models in agricultural and farming domains. And down below, you can see our ROC results for the location, purchase, and Texas hospital datasets.
So now next we can share the demo about our web-based food security sandbox, and we have a pre-recorded video. But yeah, Osama, if you want to explain the video, yeah, please.
So the As I mentioned, this is a web portal, so the authentication system is from TAC. So you need a Texas Advanced Computing Center portal account. You can just register on their website, and it's a simple account. As I mentioned, the main focus is finding similar farmers. Farmers upload their data sets. By upload, I mean it's a secure space which is owned by and operated by the farmer. Only the farmer has access to it. We can see the metadata of the data set and basic information about the data set. To do the similarity calculations, we select the data set, and based on the metadata, we find similar farmers. As you can see, these are the test accounts we have created. And there is a conversation portal. After finding similar farmers, they can talk to each other using the chat functionality. And the second thing is a collaborative machine learning from researcher point of view. They can select the similar fashion. They can select the data set based on the metadata. Collaborators are identified similar to finding similar farmers. Since it's happening as a federated learning in a distributed setting, so we identify most similar data set holders. So these are the accounts, and we have we can select a type of the model and different options, whether the model is going to be publicly available to others to use or not, and either is going to be private or not. The people we want to train the model on, whose data we want to train on, those kind of things. And we can see the models show up in our model repository section. These are the models that I have trained. The red mark means it's private and only the account owner can see it. The model information shows you the model type, the metadata is trained on, model owner, visibility. Private models are only shown to model owners, since this account owns this model. And it gives you information about the classes and class outputs. These are classification type models. The risk analysis shows you about the kind of privacy risk you infer, where we plan to integrate a lot of other kind of risk like membership inference attack risks and those. This is the playground where we have inference, so we can submit data and get the results back. I know it was running a little fast. Sorry about that.
Yeah, no problem. Yeah, thank you so much. This is great. And so yeah, I think that's the end of our presentation. But I do want to thank all the great efforts from, as you can see, the many team members within ICICLE has contributed to those different components for our food system project. Yeah, thank you a lot for their great contribution efforts. So with that, let's welcome any question or comments. Yeah, thank you all.
Yeah, so first of all, Song, Michelle, Alfonso, Osama, and for the interesting presentation. So for everybody's information, we heard from our faculty colleagues at the University of Wisconsin, and also we heard from the Case Western Reserve, Osama, and also Kaggle. So as you saw, like not only we are trying to have some like a fundamental advances in the CI and AI for the food security, but we also have the CI development, the tools which are already available at the TAC, and then the users can just go in and then work with their data sets. And but now I think we can open up for question answers, and I think I see the first question is from Rajiv.
Thanks.
Rajiv, please proceed. Yeah.
So this is the same question I asked Alfonso in sidebar. So the way this application area seems to fit within the rest of ICICLE, digital ag as well as animal ecology, right? Where this fits is that it fits sort of as providing, planning components. Once the data has been, let's say there's a farm being managed or ecological landscape being managed in real time, data is also being collected, but then you want to do some kind of planning with respect to where you allocate resources, how you do transportation and so on. So I see this application area as providing that planning layer. So if people agree, could folks who gave this talk sort of talk about some of the reusable components that may emerge that may be applicable to the other areas as well?
So I guess I'll go first. So I think you nailed it on the head there, Rajiv. We have a decision support system. And our decision support system, as they like to say in policy or public administration, our decision support system right now is not integrated across scale, across spatial scale. Right now we have a local system, we have a regional system that's emerging, we have a national system. So our hope is to integrate those scales to enable really thorough supportive decisions, especially in emergency situations, as Song mentioned. One can imagine a hurricane coming up the coast, the Atlantic coast. There's some predictive analytics that can be done for weather, hopefully, and with implications for local food security. And so across that part of the country, people can think about disruptions to national freight transportation, the freight analysis framework. They can think regionally across partners, and they can think locally with respect to how food access will be made available, especially to low-income, underserved populations. So that's part of it. Now, with respect to the other use cases, there's a few different approaches that I see here. The digital agriculture part, the privacy framework that we've tested using real data from actual farmers in the Farm to Facts platform, that data can branch across ecosystem services and wildlife ecology. That is to say, riparian areas that are consciously managed in order to enable wildlife diversity. This is possible with insights that would be shareable across farmers while protecting the actual other economic or other private sorts of data that they already have. In terms of the digital agriculture, the same thing holds true. Without revealing those elements of your practice, of your farm practices that are associated with actual yields, with actual production, with actual harvests, you can share amendments or practices that have improved your yields with other farmers, and especially those practices that might be conserving or serving the ecosystem's needs of your farm. So that is to say, practicing climate smart agriculture, or agriculture that's useful to sequestering carbon, for instance, or performing other services that will enable the farm to respond to changing climate conditions in the years ahead. I'm sorry if I said that kind of fast, but I hope that makes sense to people.
Thanks.
If I could add on to that just a little bit, Alfonso, you covered it really well. I did want to mention that the API for the freight analysis framework is for the entire freight analysis framework. It's not just for food. So I think there are 51 commodities in the FAF right now, and the Bureau of Transportation Statistics is putting out monthly updates. And so now it's possible to very easily just add those monthly updates to a report. So should there be some disruption to the freight system, it'd be very easy to identify how that might impact any given area.
Thank you, Michelle, Alfonso, and Song. Are there questions from others? Anybody can unmute himself or herself and ask questions. Yes.
While folks are thinking about that, DK, I just want to acknowledge the enormous support of the team across our activities here. Not only students at Wisconsin have been involved, but staff and students from a number of other universities. And so we just want to sit down and shout out, including an Inter-AI Institute collaboration that has been very productive and supportive of our work. So I think it's important to mention our gratitude to everyone.
We have a question from Rishikesh. Yes, please.
Yeah.
Ask
So,
question.
Song, I think you mentioned something about the innovation that you were trying to predict on the final resolution on the county level scale. Could you elaborate more on that?
Oh, yeah, sure. Yeah, because currently, as we know that for the national the sensor from the sensors, they release the data at the 5 zone level every 5 years, and actually just this year they also trying to start releasing the county level, but still at the aggregated, for example, for the whole food categories from 01 to 09. So there is no separate single separate food category release. So this is why there is still a data gap at the county level. And for the contribution we made, as you can see, and first of all, we developed this graph neural network model, and we call it's a hurdle-based GN architecture, which means that we're actually doing two types of tasks in this model. On one hand, over actually more than 80% of those links between counties has zero flows, so per certain category. So this is why the first task is actually to do a link classification to determine whether there is a specific type of food flow between two counties, and then if there is, and then is how much. So this is why it's a combination of the link classification as well as a flow regression in this one GN model. And on the other hand, because the input we only have a sufficient information from the coarser 5 zone level and from the sensor brewer, and this is why we actually develop some of the called feature enrichment at the county level, such that when we do the modeling at the county level, we actually rely on some spatial structure we learn from the coarser spatial scale, but adding those node features at the county level and rely on those spatial structure, and we are able to predict the county level flow information. So that is some of the I think innovation points we made in this model.
Yeah, that was very helpful and very detailed. Thank you.
Thank you.
Any other question from any other attendees? Okay, might be Osama or Song, this the tool which you indicated if people want to use, where they will go for and how they want to use it. Can you elaborate on that?
Yeah, Sama, I'm going to share the link and also you can elaborate. Yeah, how?
So our vision for the use of the tool is one thing is to identify similar farmers without exposing sensitive farm data. That's one thing that I believe farmers would be interested in, especially small scale farmers, for knowledge transfer, for sharing common practices and all the other things, finding in other farmers or small scale farms across state or different states based on farm profiles and that. And the other thing that we envision is that this will promote since this would bring farmers onto the platform, it would promote or help researchers have access to large scale farm data sets coming directly from small scale farms that isn't exactly available right now. Even in agriculture domain, the publicly available data sets are very few and far between for specific use cases. This would give access to a very enriched data sources coming directly from those farms, and farmers would be uh, uh, protected, and researchers would be able to leverage those data sets to come up with the mm, to train models and come up with the ways to leverage those data sets to gain insights and train predictive models. So that's our hope for the future of this system. And I would like to mention something for in terms of the previous questions asked by someone else, is that the techniques, underlying algorithms and techniques are not domain specific. They are extendable across different kinds of data sets, across different kinds of things, could be easily leverageable to logistics data sets or other things that fall under the umbrella of ICICLE. So
yeah, thank you, Asama. And then just to clarify, and also for the models we mentioned, yeah, we will release the ICICLE platform such as Hugging Face and GitHub. And for the Food Sandbox, we only have the the step-by-step play demo as a share on the box, but the full web-based interface will also be released in August. Yeah.
Thank you, Song and Osama. And for everybody's information, might be Nilima, if I can request you to post our ICICLE software release platform, like the link. For everybody's information, we have been continuously making a lot of software releases every 3 months. And as Song said, whatever you heard today, the sand food box will be made available through our ICICLE site, and also the model through Hugging Face. So everybody can please take a look at it. This we have the GitHub where we have all the details. Okay. Any other questions from anybody else? Okay, if not, I'd like to again thanks all of you, Song, Michelle, Alfonso, Osama, Kagler, for the great presentation. And in our summer series of webinars, we have one more, which will be focusing on the animal ecology. We had actually scheduled it last week, but the speaker fell ill. So we'll be rescheduling it. I believe it is on July 10th. We are heading for. I would invite all of you again to attend that webinar. We'll be advertising it very soon. So there you will see how we are taking the CI and AI for the animal ecology domain. Okay.
Yeah, thank you, DK. Thank you, everyone, for joining us today. Yeah, see you.
Thank
Thank
you
you.
all. Okay, bye-bye.
Bye.